In this video, we'll talk about exponential growth and decay. Exponential growth or decay function. Let y sub 0 be the amount or number present at time equals 0. So that's your initial amount. Then under certain conditions, the amount present at any time is modeled by your amount that you have present at any time is equal to your initial amount times e to the kt, where k is a constant, usually a constant that's given to you, or one that you could solve for. Find the doubling time of an investment earning 2.5% interest if the interest is compounded continuously, the doubling time. So we know the amount formula for compounded continual interest is principal times e to the RT. So we want to know how much time would it take to double. The doubling time means how much time it would take to double the principal. So the amount would be double the principal. Principal we don't know. The 2.5% is the interest rate. So we're trying to solve for t. So e to the 0.025 times t. So to solve this equation, if I divide both sides by p, two is equal to e to the 0.025 t. Now we know to solve an e equation, we can take the natural log of both sides. So natural log of 2 equals natural log of e to the 0.025 t. So ln of e is going to cancel out. So I get natural log of 2 equals 0.025 t. To solve this equation, I'm going to divide by 0.025. So t will be the computed amount of time here. So natural log of 2 divided by 0.025 equals 27.7, and I'm sure this is in years. 27 point, let's see, do we have to round anything? 7.3. So if I put an investment in that's compounded continuously, and the interest rate is a low interest rate, like 2.5%, that's how many years it will take me to double the amount that I put in. This is a decay problem. It says a sample of 500 grams of radioactive lead-210 decays to polonium-210 according to the function A of t equals 500 e to the negative 0.032 t. This is a decay problem because your constant is a negative number, where t is the time in years. Find the amount of radioactive lead remaining after 8 years. So all I have to do on this problem is plug in the 8. Well, let's see here. The amount would be equal to 500 e to the negative 0.032 times 8. So 0.032 negative times 8, negative 0.256. So using your calculator, 500 times 0.256 negative inverse ln, or second function ln, equals 387.1 approximately grams would be left after 8 years. Now in the next question, that should say B part, not A part, but in B part here, Find the half-life. Half-life is the time required for half of the material to decay. So if a sample was for 500 grams, the time required for half of it to go away, that means that 250 grams would be left. So if I divide by 500, of course, I'm going to have 1/2. To get rid of the e, I'm going to have to take the natural log. So now divide by negative 0.032. And time is approximately, in your calculator, natural log of 1/2 divided by 0.032 negative, and I got 21.6 or 21.7 years.